So today I'm going to make a part in the wire EDM, but first I've got to prepare the material. So it's going to be two parts cut out of this, and this is 1.5 inch square aluminium, and the parts are going to be about 1.18 inch or 30 mil. So I've got to do 2 skims and then put it in the wire EDM and cut the part out. So when you see the part, you might wonder why I'm just not going to mill the whole thing. And there's a slot that runs through the part that's only about 0.15 inch, which is doable on the mill, and with it being aluminium, it's actually not a big deal. But that's quite a long distance for such a thin cutter. And why spend the money on a cutter when I can break it, when I can do the whole process in the wire EDM much easier. So first thing, just going to give this a skim one side to make it look pretty. Just going to do all this manually because it's easier. Go as fast as I can because again it's aluminium. So okay, so one face is now skimmed, nice and pretty. Okay. So I've got to make this 30 mil. So I'm going to do another skim. Go. Gonna set Z as 0 now. Go and find my caliper. I mean, the tolerance is pretty open on this, so let's see what this measures first. So it's 34.99. So I'm going to take 4.99 mil off. 4.99 divided 25.4, 1964. I could probably just take that off in one go. I mean, I'm not using coolant either, so I don't want to ruin the finish. So I'll take 0.15 off. Okay. And then I'm going to go 0.196. Well, I mean, don't have to be that accurate with it, but 1964. move that out of the way. Finish is good. There we go. 30.01. So next is the wire EDM. Make sure it's not full of water before I open the door. So with a wire EDM, you want the nozzle to be as close to at least one side or both sides as possible, because the water flushes away the debris, and the faster you can flush debris away, the faster it will cut. You get these little clamps with holes on, and they bolt underneath a part like this. There is also a second rail I could put on here, so if you got big parts, you know, you can stabilize both sides. Now this part doesn't matter too much if this is accurate this way, because I'm cutting the whole part out. But the machine is generally set up really accurately, so the next thing is I'm going to feed my wire through, which I got to just connect the air again. Okay. Actually, one thing I should mention before I do that is, show me on the right screen. Ready for a new pen, and this thing is got a loose connection. There we go. So you want to be as close to the part as possible. And ideally I put the nozzle right up to it, but the thing that's going to get in the way on this part is my clamp. So I'm going to move my head down as close as possible to the clamp. So that's as close as we can get down there. So now I'm going to shut the door, and I'm going to make a note of that. So 2.316, we'll just call it 2.32. So in my program I have a main program and then a sub program. The main program basically tells what power settings, that kind of thing. So first thing, HPA is the height of our part, which is about 1.2 inch. Then this second one is going to move to a height that we just recorded there. E25A is a technology for the wire, so these are power settings, and it'll work out the power settings in combination with the height and a few other bits. LT25 means hard brass wire, 25 is 0.25 mil wire, and A means steel. Even though I'm doing aluminium, it's actually cuts really close. So I mean, the speed is considered like 4 times faster than steel, but that doesn't matter. And then SPG is called subprogram A, and MFF is duty cycle, so 100 would be 100% power, 70 is 70% power. If I go 100 it might break wires, if I go 70 it's going to run pretty conservative. And even though it's at 70, you might think it's going to run 70% of the speed. Realistically, it's actually going to get pretty close to 90-95% speed. So save file, exit. So if I hit this key, it's going to feed the wire through. So this uses high pressure water, and it feeds the wire through, and the wire goes through the middle of the water. Just blowing water everywhere. So it's now fed the wire through. So it sends a set amount of wire through the system until it hits the cutters, and then it'll stop. So you might be able to hear the wire cutting now. There we go. So now we're going to probe the part. So we're going to measure in edge. So if I press Y plus, it's going to tension the wire, apply electricity, and then touch on the part. And once it detects a circuit, it's then going to back off, which it has done. The wire thickness is 0.01 inch, so to the middle of the wire it's going to be 0.005, just like that. And then we do the same with X. Measuring edge, move X minus, so it's going to spin the wire, touch on the part. There we go. So set X, and that's going to be plus 0.005. There we go. So now I've just got to make my program, load it onto the machine, and then I'll show you the next step. So I'll put the program in the machine. Now wire EDM prefers to be cut in between something, so it likes to have material on either side of the wire. So even though I've set eye corner as 0 there, I'm actually going to move in Y by point, let's say 0.04, and I'm going to do the same with X, minus 0.04, and then I'll set that as a 0 point. And by doing that, it means we're actually going to cut material, and we're going to be inside the material. So I put the program on. If I go on program execution, draw screen and graph, press go, it's going to cut our part. Everything looks correct, so I'm starting here. I'm going to cut along, cut all the inside, come back around there, because we're supporting the material out here. If I start the cut here, you know, and went around and then did all this, it's going to be quite fragile. Alternatively, I could start the cut there, but I'd have to cut in and then come back. That's not a bad option, but everything looks good. So next step, execute, program execution, cut, press go. So now it's going to fill the tank up. Once it hits this level, it's going to stop filling, and then it's going to adjust this gate, which then controls the water level. So now it's in place, and then once the water level's right, then it'll start cutting. So the water in a wire EDM is super pure, like way more pure than what comes out of the tap, and it has a system that deionizes, takes all the minerals, everything out to make it as less conductive as possible. So you see there's a lot of contact there, that's going to move in against the wire. That'll provide us electricity. And the water, if we look through here, should be able to see it start cutting in a minute. Just like that. So aluminium's quite violent when it cuts, but it cuts like 4 times faster than steel. So now we're going to info screen. So this is the flushing pressure. This is going to start increasing, and things will start speeding up. So this is our speed, this is our cubic inches per hour. Steel will run about 8, stainless might run 10, maybe 12, and then aluminium will run between 30 and 40. DIO, that should be around 15. I need to replace the resin in this. Temperature doesn't matter, it's not an accurate part. E2 is our power setting, determined by the height of our part. D0, that's like cutter compensation, so that's compensating a 5 thou wire plus about 2 thou spark thickness. Then ST is our machining strategy, and that's how hard it's pushing. So this is going to start moving towards 0. And when it starts moving towards 0, that's when you might start breaking wires, but it's starting to cut as fast as possible. So we can see our speed slowly increasing. It's working things out. You know, we can see our speed going up. Graph, don't know why graph never seems to match my simulation, but we've curved in, we're moving along, we're somewhere about here. So now it's just keeping an eye on things. On a one-off, you kind of want to watch it, see what it's going to do. But the wire EDM's kind of nice that if the wire breaks, it'll rethread the wire and it'll automatically slow down a little bit. So I can go and do something else while this runs. Yeah, you can see the speed's ever increasing. The strategy is almost at 0. The flushing pressure is getting higher. I can also go in my generator settings, see where things are at. Increasing wire speed can increase the speed, but sometimes it makes the wire kind of vibrate a little bit and slows things down. Injection is injection pressure. Increasing that almost always makes things run faster. I'm just going to kind of leave it everything as it is. And then our duty cycle 70, I probably will increase that. Actually my wire speed I've been reducing down to 11, and it's been saving me a little bit of wire, but it's not been affecting the cutting speed too much, so it's kind of well worth doing that. And then these settings are kind of like power settings. I'm just going to leave those. The machine kind of does its own thing. Yeah, see our speed's getting much higher now. Around 30 is kind of a good spot. That's if I quote aluminium parts, I'll probably quote them at around 25 to 30 and just hope it runs faster. So I can't really see the wire now sparking because it's in between material. And aluminium is quite messy when it comes to wire EDM. Clogs the filters really fast. So even though it cuts faster, you've got to take into account your filters. And there's a lot of filters on this machine. Like this one takes 16 big filters. And then there's another filter in the back that kind of filters for the nozzles. That one I replace every week. So our speed's not really increased anymore. I could risk it and increase our duty cycle to say 80. So you see the speed starts increasing. I'm not going to go any more than that. I don't want to break wires. Sometimes it's nice to run it a tiny bit slower than run it too fast. So the part is getting real close to being done. It's been running for almost an hour. So when it gets to the end, it either speeds up or you hear like a weird sound like I just did then. So I'm just going to move the wire up out of the way. empty the tank. So just empty it enough. I don't need to empty it all the way because I got another part to make. So I'll try and pull this out. So this is the finished part. So you can see that would be quite difficult to mill, that slot through there. So here the part's complete. Well, complete for the wire EDM. I still got to machine a small feature in on the milling machine. I always think it's interesting to look at the offcuts. It's always a good idea to clean the machine down at the end of the day. I mean, everything's stainless in this, but if you leave pieces in like this, they'll just oxidize. So thanks for watching. Lots more to go. Trying to do the YouTube thing, so a few machines. These are hopefully going soon. And then down here I've got 2 mills, 3 lathes, a die sinker, my compressor, and then in the middle there's a V12 engine I'm making a motorcycle with. So I'm using the wire EDM to cut the gears for the transmission, because I'm going to make a 2-speed with this. So make sure you subscribe. Thanks.